Welcome to Study Loop.
Okay, we have 0.25 molar glucose. We need to prepare a 1 to 50 dilution, and we want 50 mils of that, right? So the question is, how many grams per liter will be in our 50 mil dilution, or in our 1 to 50 dilution, right? So the first thing is just let's establish how do we get our 1 to 50 dilution such that we get 50 mils, right? So if we want to total 50 mils, right, we need the amount of glucose solution. So let's say glucose solution plus the amount of DI water we add has to equal 50 mils, right? But we also know, right, that the glucose solution has to be 1/50th of the 50 mil, right? Like we need a 1 to 50 solution. That is to say 50 times the glucose solution has to equal 1 times our final solution in terms of concentration. Hopefully that makes sense. Right, that's like how to describe this? I think it'll help if I point out that we also know that our final solution has to be 50 mils, right? So that's like saying that if we divide both sides of this by 50, we need 1 mil of our glucose solution, right, to go into our final solution. And if this is 1 mil, that means this must be 49 mils. Okay, so then we've got basically the recipe for how we're going to make this dilution. We're going to pour 1 mil of our glucose solution, pour 1 mil of glucose solution into a 50 mil volumetric flask. Then fill flask to 50 mils with DI water. Great. So that's our recipe. And now the question is, how many grams per liter is in this dilution, right? So we had 0.25 molar, right? And we put 1 mil of this in 50 mils. Does that seem good? A 1 to 50 dilution? Right. So what is 0.25 divided by 50? That's 0.005. So now we have a 0.005 molar glucose solution. Okay, so how many moles per liter is that? That's 0.005 moles per liter. Okay, but we want grams per liter, right? So we know in 1 mole, there is 180 grams. They told us that in the problem statement. Okay, so now we just need 0.005 times 180, and I get 0.9. Moles cancel. 0.9 grams per liter in our 1 to 50 dilution.